Hi, this is Professor Evans, and this video is for the students in COP 3330C, which is Object Oriented Programming, offered at Valencia College in Orlando, Florida. This video is going to focus on the last module of our course, which is database connectivity. And in this video, we're going to explore databases using SQLite and IntelliJ. The objectives for this video are that you will learn how to write code that creates and modifies a relational database. We're going to start learning how to do this by learning how to open, read from, and write to a database in SQL. And we're going to do all of that from the command line. Next, we're going to learn how to modify that same database using a GUI. And then finally, we're going to learn how to interact with a database using Java, IntelliJ, and the SQL Helper plugin offered for IntelliJ. So the tools that we're going to explore in this lesson are SQLite, IntelliJ, and SQL Helper. Again, that's the plugin that you will download for IntelliJ. So the beginning of this lesson starts with how do we create and use a database using a tool called SQLite. A video has already been provided to demonstrate the basics of using SQL to create a database from the command line using SQLite. That video is already on Canvas, and you need to have watched that video before you watch this one. So if you haven't already watched that video, and it looks like this, please stop watching right now, go back and watch that video first. In that video, you're going to get an introduction to how we create a database from the command line. In the video, that particular host is using MySQL as the tool, but you're going to replicate everything you see using SQLite instead. All of the directions for accessing and downloading SQLite are on Canvas. So again, please do not continue with this video until you have already watched the Java JDBC tutorial that I have provided for you on Canvas first. So, assuming that you have watched that video and you're ready to continue, the next thing that we're going to discuss is how we can look at a database from a GUI. A GUI stands for Graphical User Interface, and so rather than always having to rely on a command line, SQLite also comes with a GUI that you can use to view and edit the database. I'm going to show you a demonstration of that in just a minute. But to access that GUI, you can go to wherever your SQLite download is stored, and there is a folder there called GUI. Once you go into that folder, look for the application called SQLite Studio. That's going to be your graphical user interface that will allow you to add, edit, update anything in your database that you've already created from the example in the previous video. So right now you should have a university database already created based on the previous video. And I'm going to show you in just a minute how you can open up the GUI that comes with SQLite to view that database and modify it. So once you are able to use the GUI, the next thing you'll want to do is explore it, play around with it. Notice how different it is to add or change information compared to the command line. Just remember that all changes must be committed to the database. I will show you what that means during my demonstration. So after I demonstrate to you what the GUI looks like, the next thing that we're going to do is learn how to access a database with a Java application. So we're going to go into IntelliJ, and we're going to learn how we need to set up an application to access the very same university database that we already have. So in order to do that, we're going to need a tool called SQL Helper. It's an add-in or a plugin for IntelliJ. Instructions for installing SQL Helper are provided on Canvas. It's a simple process, and you can perform a quick Google search if you're not sure how to add SQL Helper to IntelliJ. Once installed, you should have a blue SQL Helper icon showing within your toolbar in IntelliJ. From there, you'll be able to add the database you've already created, and then you can view, edit, or query your database file. So it also has its own GUI that you can use as well, or in addition to SQLite's GUI. The nice thing about SQL Helper is it has a generate code button that will create some of the necessary Java classes you need to connect to your database and then read or write to it. In order to use the code that is generated from SQL Helper, you will have to write your own application and call the necessary methods. So I'm going to show you how to do that today in this video. So as a wrap up of this very quick introduction, from here you're going to see a live demonstration of the SQLite GUI, the SQL Helper GUI within IntelliJ, and then creating a Java application to connect to your database within IntelliJ. So from here on out, I am going to invite you to follow along with me. Please already have SQL Helper installed within your IntelliJ application so that you'll be able to follow along seamlessly with me. Keep in mind that after we finish this demonstration, Project 8 will be an assignment where you're going to make your own video showing that you can create and modify a database from the command line, from a GUI, and through a Java application. There are specific instructions that explain what your video demonstration must show, so please just follow the directions provided on Canvas for Project 8. But in order to complete Project 8, you'll want to make sure that you follow along with everything that you see me doing in this video so that you know what you'll need to change in order to complete Project 8. So from here, I'm going to pull up the folder where my SQLite is installed. It's right here. And there's a folder here called GUI. And within that folder, there is an application called SQLite Studio. That's the GUI you can use to access the database that you've already created from the prior video, the university students database. So when you open the GUI, you're going to come up to the top and click Add a Database. You're going to search for your database wherever you have that saved and hit OK. If you double click this, you'll connect to the database and it will show you all the tables that are within the database. In our case, we only have one table, which is our engineering students. Double click that and then you'll be able to see the structure of that database. So we can see each field and its data type, where the primary key is, etc. The entire schema that we typed in on the command line is now visible to us here within the Structure tab. In the Data tab, we can see all of the data currently contained in the database. Now, this is my unique data that I decided to add. At this point, you should have your own database with some of your own data added into it based off of, again, the first video that you watched. From here, I can make changes. I can add new column or new rows. I can delete a row. I can change the information here. So if I wanted to change the name here, I can just double click and I can change the name. However, it's not saved to my database file unless I commit the change. And that means I'm going to have to come up here and click this green arrow to commit it. If I change it here and I don't commit it, then it won't show up if I were to open the same database file from the command line or from any other source. So if you make changes within the GUI, just make sure that you commit those changes so that it is actually saved in your database file. So again, I can add a row here if I wanted to add some new information. I can delete a row just by hitting the delete button. Just remember that whatever you change, make sure you commit your changes. If you were to change your database from outside of the GUI, let's say that you went back to the command line and added a new piece of information, you can refresh your database here and that change will show up here when you hit the refresh button. These other tabs show the constraints. For example, some of these values here are not allowed to be null, so we can see that here. There are other settings here that we really won't explore in this video, such as index and triggers. And then in the DDL tab, you can see the schema for the table. This is exactly what you typed in your command line to create this table. So this is some of the things that we can see just from the GUI that comes with SQLite. And whenever you're done using the database, you can disconnect from the database when you're done, and you can exit the program when done. So that's the GUI that comes with SQLite. I encourage you to take a second to play around with it, add some data, take away some data, go back to the command line and see that your data is stored properly and that you can access it from multiple points. And then when you're ready, pull up the code that you wrote with the first video that allowed you to access that database from a Java application. So just to refresh, this is the code that was written from the video where we can access the database that we've created to print out information and basically perform a quick query and print it out. So as a reminder, your code in IntelliJ will not run, and you'll get an error like this if you haven't added your SQLite jar to your external libraries. So just as a reminder, directions on how to do that are provided on Canvas, but in case you need a refresher, you'll have to go to Project Structure, you'll have to go to Dependencies, and then you want to click the plus and add a jar or directory. Then you're going to navigate to wherever you saved your SQLite or wherever you installed your SQLite. And within that folder, there is this jar. You need to add that to the class path, or you need to add that to your external library in order for your code to compile and run correctly. So we're going to click Apply and Close. And now you'll see that this is listed here. So I'm going to go ahead and try to run the code that was created watching the first video. So here's my database. I can see that the connection to SQLite has been established. There's my information that is printing out, and that's just printing out basically from the code that was written in that video. I did make one small modification. I made 2 queries so that I could run them both consecutively. And you'll see right here is where I run the second query, and right here is where I run the first query, and then here is where we print out the result of that query. So in the first query, we can see that we're printing the entire table, and in the second query, we're printing a certain set of students based on student ID number. So in that video near the end, that host made an excellent point in that this code works as long as you are doing a query of exactly 6 things that you want to print out. Notice we have a for loop, and it's not dynamic. So if I want to change the query to not print out 6 columns of information, my code automatically doesn't work. Also, what if I wanted to use this piece of code to add something to the database or delete something or update something? This code works for making a quick query and printing something out, but it's not very dynamic for being able to do more than just a quick search. So now I'm going to show you how we can make a more robust Java application to access our database. So at this point, you should have SQL Helper installed, and if you do, you have this blue S right here at the top of your screen. So the first thing that I want you to do is click that S, and we're going to go to Open. From PC, you're going to navigate to where your university database is saved. So in my case, it is stored in my SQLite folder right there. So I'm going to open my database, and I can see that the university name is listed here. And if I expand tables, there's my engineering students table, and there's all of my data. So this is the GUI that comes with SQL Helper. Notice that you can add a row, update a row, and delete a row right here. So if I wanted to make a quick change, I could do it right here from the command line. I can also type in a SQL command right here if I wanted to run a quick query and see the result come out right there. So just anything that you would do in the command line to run a query, you could run it right here, and you could see the result right there. So as an example, this was one of the queries we had from our code. I'm just going to paste that in there. hit create, and there's my result. So any query you want to run, you can type it in there, hit create, and the result will come up in the results window. So here's a second GUI that you can use to manipulate your database. Now, the next thing that you're going to do here is click the Generate Code button. In this first window, it's going to ask you which tables you want to generate code for. We only have one table, so this says engineering students. But if I had 5 different tables, they would all be here, and I would have the option of deciding if I wanted to create code for all of those tables or just 1 or 2. So it's up to you. If you intend to do something with every table in your database, then you'd probably want to select all of them. If you only intend to write code to manipulate one particular table within your database, then just select that one that you want. You can leave the folder path as is. Package name and main class name are the names it's just going to give the code that is generated here. By default, it says DB Helper. You can change this to whatever you want if you like. For now, I'm just going to leave it as the default name. And you're going to hit generate. And you get a note that says Java code was generated, and we're going to hit OK. And I'm going to close this window. So at this point, I'm going to save. I'm going to close the project and open it back up. I'm not sure why you have to close it and open it back up, but when you do, you'll see a folder here, DB Helper. I'm going to go ahead and just put that down in my source. And within DB Helper, I've got 2 Java classes. Let's take a look at them. The first one at the bottom is engineering students. That class is always going to have the same name as the table you just created code for. And let's take a look at what's in here. So we have a public class called engineering students that extends DB Helper. That's the other class we have here. And if you scroll through, you'll see that we have all of the fields from our table created here. So everything that we created, like in terms of the schema, it's all right here. And then we have some methods. Each one of these methods will allow us to perform an action on the database. I'm going to go ahead and add some comments to each one of these methods to help explain what it does. And I encourage you to add these same comments to your code as we walk through this file. So the first piece of code, or the first method that we have, is called prepare SQL or prepare SQL. And I'm going to go ahead and copy in some comments here. So prepare SQL, its purpose is to prepare the text of a SQL select command, specifically the select command. Notice that it returns a string. So it just prepares the text of a command that we're going to eventually use to query our database. So it returns a string, and it has these arguments. The fields are the fields we want to display in the output. What field is the field we're searching for? And what value is the value we're searching for within that field? Perhaps we want to search for all students who are majoring in music, for example. The sort input or argument, you can basically add ASC or DESC if you want to specify a sorting order, ascending or descending, and then sort field, and that's the field that the data will be sorted by. So let's say that I want to search for all students who have a department listed as music, and I want to sort that in ascending order by student ID or by student last name, for example. This method will prepare the text that I need to create that SQL select command. So notice that all of the arguments are provided here, and then we're just creating a string. That string is continuously concatenated with the arguments that we've supplied here in addition to the required SQL text. So this is just going to return a string with the SQL command we need to run a select statement. The next method that we have is called insert. Insert will allow us to insert a new row. into the database. So it'll insert a new record into the database, or you could think of that as a new row. It does not have a return type. It's void. It does not return anything. The arguments are each field listed in the table from the database in order. So you'll notice that if we're going to add a new row, we need to include student ID, department, first name, last name, pass out year, and university rank. So those are the arguments to our method. And from there, this method will basically create the SQL command needed to insert a new row into the database, and it will insert it for you. Notice that right down here, we have super.execute. So keep in mind that this class extends DB Helper. So it's going to inherit the methods from DB Helper. If I go into DB Helper and look at the execute command, what is it doing here? It attempts to connect to your database and then execute the command that is passed in. So if you look at the code that was written for the JDBC tutorial, within our code, we manually connected to the database and then tried to run a query. With this SQL Helper, it provides code in such a way that you just have to call whatever method you want to call within engineering students. And through inheritance, if I call the method insert, I'm going to end up calling this method execute, which is going to connect to the database. And then it's going to execute the command that is created within this method here. So by calling method insert, it takes care of connecting to the database for me and passing along the correct SQL command to add a new row to my database. So that's the insert method. Next, we have the delete method, very similar to insert. It's going to take information from the user and its arguments to delete something from the database. So it'll remove a record from the database. Return type is void, does not return anything. The arguments are the field or key used to determine if a row should be deleted and the value that should be removed. Again, due to inheritance, this executes the execute method found in the parent class. So we can see here that we're going to pass in the field and the value that we're planning to delete. And it's going to call the execute function from dbhelper.java, and it is going to execute this SQL command. It's passing in a string to execute. That string represents the SQL command. In this case, we want to delete. And that SQL command will be run within our database. So it will delete from the table name, which is declared up here. That's our table name. So it'll delete from our table name. Where the field we supplied has the value we supplied. It'll delete those rows. That's your delete function, or method in this case. We have an update method. Similar idea here. We can update a record in the database. It's a void return type. We have to pass in the field that is used to determine. Oops, this should be updated. So we're going to pass in what field we're going to update and the value that we're going to update it to. So here is our method. And really it's again just going to execute that same method from DB Helper. And it's just passing in the SQL command needed to change a value in the table. So SQL Helper is giving us methods that generate the SQL commands we need to add, delete, update, etc. The next one we have is select. So this is when we want to run a query. Here's my comments for select. So select will complete a SQL select command. Notice the return type is different here. It's an array list of objects, meaning it's a 2D array of objects. So the data returned can be any type. We're going to get a 2D array. Basically, we're going to get a table back because we're searching the table for a particular data set. And what we're going to get back is something that has both columns and rows. We're going to get a table back. So in this case, the return type is an array of array list objects. So in order to run this method, we're going to enter these arguments. The fields are the fields we want to display in the output from our query. What field is the field to search within, and what value is the value to search for within the field? Again, maybe I'm looking for student IDs that are, 1, 2, 3, 4, 5, 6, 7. Maybe I'm looking for all people with the last name Thompson, whatever the case may be. And then, again, we have our sort and sort field arguments. So the arguments here for select are the same as the prepare SQL method. And if you notice, what's happening down here is we're calling execute query from the parent class. And what are we passing in? The output from prepare SQL. That's why these fields match. So this method is going to take all of the arguments here, run it through the prepare SQL method. The output of that is going to be a string, which is our SQL command that will then be fed as an argument to this method, which runs from the parent class. So if I go to DB Helper and look at the execute query method, which is right here, it's going to take a string, our SQL command, and it's going to return a 2D array of objects. That's going to represent the result of that query. And right here is where it is going to run that SQL command, grab the result. The rest of this sets up our result so that it can be returned as an array list of array list objects. So that is select. The next method that we have is get execute result. This one will perform a search of the database where the string query, our only argument, is a SQL command that would be entered on the command line. So if we are not going to use the select command, maybe we want to do some other sort of SQL command, this method will just take that SQL command as is and execute it. So we pass in a string, which represents our SQL command, and it's going to execute that command using the execute query method from the parent class. So the difference between get execute result and select is that this one is specifically made to run a select statement, specifically made for that type of statement. But there are plenty of other SQL commands we could run. And if we want to run something else that doesn't fit into this category, I can use the get execute result method instead. The next method we have is execute. This one does the same thing as the first one, or the one before, but what's the difference? Take a look at get execute result and execute, and try to take a second and figure out what's the difference. They both have the same purpose, but there's one difference between them. This one returns a 2D table. This one returns nothing. So You might use the first if you're doing a command, such as some sort of query that you would expect to get a result back on the screen. This one is used when you want to execute some sort of SQL command that would not return anything to the screen that you would want to print out. So if you're going to add, delete, update something, we don't need to have a return type because nothing would be returned in those instances. So that's the main difference between get, execute, result, and execute. If you think about it like this, get, execute, result has a result. Something is being returned, whereas execute is not going to return anything. They both ultimately do the same thing. They perform a SQL command where the query argument is the SQL command, the same thing that you would normally type on the command line. And then our final method in this class is default table model. It does almost the exact same thing as select. If you look, the arguments are the same. But this time, instead of returning an array list of array list objects, it returns a type called default table model. You can think of this as a vector of vectors. In other words, another way to represent a table, another data type available to you within Java. So default table model will run a query, return the results of that query in terms of rows and columns. It's a vector of vectors. I'll show you how to access this in just a few minutes when we write our main application. So when you run SQL Helper and you generate that code by using this button, I'm not going to do it again, but you generate that code, you'll get DB Helper. You just have to refresh your project. I usually just close the application and open it up again, but refresh the project and you will see DB Helper added, and these are the files that come out. And it's your job now to just know, how do I use these methods to do what I want with my database? So in addition to DB Helper and engineering students, we're now going to need to create our own Java application to call these methods and show the output on the screen. So I'm going to add a new class. I'm just going to call it University Database. And in this class, I am going to show you how to call each of the methods in the engineering students class. So I'll do a demonstration of how each one of them works. And then you'll be able to use whichever ones you need for your Project 8 assignment. So I am going to import a few things up here, and you'll see why we need them as we go. And now I'm going to start with writing a main class. So the first thing that we're going to need to do, if we want to run any of the methods in our engineering students class, we need to create an instance of it. We need to instantiate that. So I'm going to instantiate it right here by calling engineering students, and I'm just going to call it DB1 for database 1, is equal to new engineering students. So I've now instantiated that class so that I can call the methods within that class. And the next thing I'm going to need to do is have a place to store my data if I run a query. This doesn't quite fit, so change my comment there. Next, we're going to create a 2D array list to hold the results of a query. This can hold columns and rows of any type, because remember, we're using the object class right here to declare what type is stored within our 2D array list. So data is going to be the place where I am going to, when the query returns information, it's going to be stored in data. So the next thing I want to do is perform a query and just print out the database. So in order to print out the database, I need to perform a query of the database and store that in data. So here's how I can use get execute result. Where I just want to run a query, I can put any query I want in here. In this case, I'm just going to select all from engineering students. And the result of that is going to be stored in data. So remember that get execute result. If you go back to engineering students, get execute result, here's the return type. So when I store that in data, those types are going to match. Now I have the data by running this, but now I want to print it out to the screen. So let's talk about how we can print it out to the screen. I can create a for loop where I can create a record. I am going to parse through data, grabbing one record at a time. Notice the type that I've defined record is right here. So I'm going to parse through data, getting one record at a time. By declaring it as this type, I can easily print out each record or each row by using the toString method that comes with this data type. So this for loop is just going to go through data, get one row at a time. Each row will be stored in record. Record will be printed out, and then we're going to go through and get the next piece from data and print it out until there are no more. Now, let's say that I want to delete something. Let's say I want to delete a row of data from the database based on student ID. So I'm going to go into my database and look at 2 student IDs I want to get rid of that currently exist. When you type this up, you want to make sure that you pick 2 IDs that you currently have in your database, because more than likely you've got different data than I have in mine. So make sure your student IDs are something that actually exist in your database right here. I am going to just print a quick message to confirm something was deleted. And now I want to print all the records again. So each time that I want to print the records, I need to run a query to grab everything in the database. And then I'm going to run this little loop again. Since I have a feeling I'm going to be printing a whole lot, I'm going to create a static method outside of my main method to let me quickly just print the database. So I have a public static void method called print database where I'm going to pass in that 2D array list of objects. I'm going to call it data, and there's my for loop. So instead of running this for loop over and over and over and over, I am just going to call this quick little method here instead. So now I am going to print a message to the screen, letting the user know I'm printing the contents of the database, and now I'm going to reprint the database now that I have deleted something. Let's say that I want to add a new entry to the database. There are multiple ways to do that. You have 2 different methods within your engineering students class that will allow you to do that. You can run the execute method and type the query in yourself. You can run the insert method, where all you have to do is provide the values for each field, and it will create the SQL command for you. So I'm going to run both of these just to show you how you can use each one. But when you do your project 8, you can pick which one you want to use to add a new entry to the database. So now that I've added something, I'm going to go ahead and print it again. This is just so that as the code runs, we can see what changes have been made. So I'm going to pull all records from the database and print again. Same thing as I did after deleting. Now let's say that I want to run a query. One way to run a query is to run the getExecuteResult method. So I'm going to call that method from my db1 variable. I am going to pass in the query. This is the SQL query, just all the text of the SQL query. So this is one way to do a query. And I'm going to get the results from the query and print them out here. A second way to do a query is to use the select method. So we have more than one way to insert a new entry. We have more than one way to perform a query. We can run any query we want with the execute result. In this case, I'm doing a select, but it can be anything I want. And if I know I'm going to do a select, I don't have to type all this out. I don't have to come up with the SQL command myself. I can just pass in the fields that I'm searching on or looking for and what I want to return, and this method will do it all for me. I'm going to go ahead and print out the results of that query. Right there. I'll even make this first and second. Lastly, what if I want to use the default table model to print out a query result or the entire database? I'm just going to show you how to use it, even though it's one of two options for printing out what you have from the database. So far, every time we've wanted to print something, we used this variable right here that we created called data, and we gave it the type of the 2D array list. Well, the other way to print out the database is to use that last method, default table model, where you just have a different return type. You get the same information, different return type. I'm just going to show you how to use it so that you know how to use either option. So the first thing we're going to need to do is create a new variable with a type that's going to match the return type of the method we want to use. From here, I can run select to table, where I pass in the fields that I'm doing my query for. It's the same query that I'm doing up here. It's the same query that I'm doing up here. But instead of using the select method, I'm just using the select to table method. Same query, same result, different return type. That's all that is. Now, once you get the table back, it's a vector of vectors. And if you go look up the documentation on this data type, you'll see that there are methods you can use to access the information stored in table and print it out. Namely, you're going to access the information by looking at each column and row, because you literally have a table with columns and rows using this data type. So here's what we're going to do to be able to print out everything in our default table model data type. Just going to create a quick dummy string called data2, set it equal to null. I'm going to let the user know I'm printing out my table now. And we need 2 for loops because we need to access each individual cell by row and column. So I have int row equals 0, row is less than table.getRowCount. So see, those are those methods I was talking about that allow you to easily access information for anything with this type. So because table has this type, I can call a method called getRowCount. So I know how many rows it has. Then I can nest in another for loop where I can get the number of columns using .getColumnCount. From there, I can call a method called getValueAt, plug in the row and the column that I'm at, call a toString method, and it's going to print out each cell in your table one at a time. Starting with the first cell in the first row, it's then going to move to the next column on the right, and then it's going to continue through until it has gone through all the columns. It'll return back to 0, go to the next row down, and print it all out all over again. I also added a pipe just to separate the data in my output. So now I have done a method call for each one of the methods shown in engineering students.java, except for prepare SQL. Notice this is a private method. It's not meant to be called outside of this class. This method is called within another method in this class. It's not meant to be called from outside, so that's the only one you'll see that I did not call. The rest of these are called somewhere in the code that we just wrote. So now you have a basis or a framework for understanding how to call each one of these methods that will access your database and perform an operation. Now I'm going to go ahead and run this. And let's take a look at all of our results. So in the beginning, the first thing that we did was just to print out what's in the table currently. And that was this. That's what's in our table. The next thing we did was delete 2 things and then print a message to the user saying something was deleted. And then we printed the database again. So if we go back to the code, I wanted to delete student ID 14578. So in our original table, I wanted to delete 14578. That was Richie Rich. And I wanted to delete student 123456, which was Sarah Sampson. So here is the table before deleting. And here's the table after. And we see that Richie Rich and Sarah Sampson are gone. The next thing we did in our code was to execute adding a new entry where I actually added in Sarah and Richie back to my table. So now they're back because I inserted them in again. Next, you can see that we performed a query, this line right here, where we are doing a query to look for students who have a pass-out year of 2023. So this information is our first query. Our second query was looking for students who had a department of music. So the first time that we did that query for students in the music department, we used a select method. The second time we performed the same query, we did select to table. So we got that data in a table and we printed out the table using the rows and columns. Here's that table using that for loop, that nested for loop, using the rows and columns to print out the table. So it just shows you that the execute or select to table method and the select method will both work to give you the same result. It's just a matter of how you want to get that result and how you want to print it out. The one thing I did miss was putting in the update function where we update something in the table. So let me do that real quick. I'm going to add some code to update right before I add a new entry. I'm going to put it there. All right, so I currently have my table. Looks like this when we start. I am going to grab I'll leave it this way. I'm going to grab the students with the first name Alexa and pass out year 2018. So basically what that means is I'm going to look for any row where the pass out year is 2018 and update the name. Since I've run this code before, this has actually already updated my database. So I'm going to change the name here to something else. So now what we should see is that this row right here, where the pass out year is 2018, when I run my code again and perform the update, this name should change from Alexa to Thomas. And I should see a note saying that it was updated, and then it should print out again. So now that I've added that, I'm going to go ahead and run my code one more time to see that change. Okay, so there's my updated command. And here's before the update. Here's after the update. So that's the update method as well. And those are all the methods now that are in your engineering students class. So hopefully through this example, you can understand a little bit more about what each method does within the engineering students class that was created for you by SQL Helper. And hopefully now you know how to call each one of those methods to execute a query, insert a new piece of information, delete information, etc. From here, I would encourage you to play around with the methods. Try to execute different types of queries. Try to add, modify, or delete different pieces of information within your database. Get comfortable with calling each one of these methods and knowing the right way to send in your arguments to get the result that you want. Once you're comfortable calling the methods, then you should proceed to Project 8, which will explain how you're going to want to update your university database, your main application, in order to prepare for your video demonstration. So if you have any questions on this video, please send me a Canvas message or an email. Thank you for watching, and until next time.